right, so we're going to be working on a new lesson where we are going to be talking about inequalities. And so we've seen in the past that we've talked about equations. And when we talk about equations, remember we're talking about two expressions that are equal to one another. So an example would be 1 plus 1, that would be equivalent to 2, right? So those are what we will call equivalent expressions. 1 plus 1 and 2 are equivalent expressions. So this is an equation. However, now what we're going to be talking about is inequalities. That means that one side is going to be more or less than another. It could possibly be equal to if we're including that in there as well. But let me show you what we're talking about. An example would be, let's say that we have 2 plus 3. Okay. We know that 2 plus 3 is 5, which means that that is greater than 4, right? Um, but of course, because we're talking about algebra, we're going to be seeing some variables inside of the problems that we're looking at. So we're going to keep that in mind. We're trying to make sure that anything that would make this a true statement, for example, if I replace this and put an x in here, x plus 3, this basically means that whatever I place in here for x, it has to make sure that this statement or this expression, whatever the value of x is, plus 3 is going to be greater than 4. So let's see. What if I replace x with 5? So that would be 5 plus 3. That's 8. And yes, that's true. That's greater than 4. What if I plug in 1,000? Okay, plus 3. Of course, that's still greater than 4, right? So there's so many answers or possibilities. There's an infinite amount of possibilities that could make this statement true. So what we want to do, instead of trying to figure out all of the different numbers, you'd be writing until forever to try to figure that out. But what you could do is we could isolate the variable like we've seen in the past. So an example is x plus 3. That's going to be greater than 4. What we're going to do is isolate the variable. So we're going to do the same thing that we've done before when we talked about equations. And because we are trying to isolate the variable, remember we are going to work in reverse order. Addition and subtraction first. We want our value to become equal to 0. And if we have multiplication and division, if we use the inverse, we want that value to become equal to 1, right? And what we're trying to do is make sure that x is on one side of the equation, inequality, all by itself. And then that way we know what values would make that statement true. So I see that x is not isolated because we are adding 3. So what I'm going to do is subtract 3 from both sides. And now we have x, positive 3 minus 3, that cancels out. And we are left with 4 minus 3, that is 1. So whatever the value is that we put in place of here, it has to be at least, or I'm sorry, it has to be greater than. It has to be greater than 1, okay? So let's see. What if I made that 1? 1 plus 3, that's 1 plus 3 is 4. 4 is not greater than 4. So that would not be a true statement, right? So that's why we're saying that x has to be at least 1. Okay. Or I'm sorry, it has to be greater than 1. So what could make this a true statement is, what if x was 1.01? Okay. So if we have x is 1.01 plus 3 is greater than 4, now we have 1.03 plus 3, that's 4.01. And yes, that is greater than 4, right? So that is a true statement. So remember, there's an infinite amount of answers that could make this a true statement, that could make this a true statement. But what we need to do is figure out what type of symbol or system could we use so that we could let you know here's where all those choices lie. So what we're going to use is actually a graph, a line chart. So for example, I'm going to plot this on here, and I'm going to go back to my example up here. X plus 3 is greater than 4. So we'll start back up to here. Okay. So x plus 3 is greater than 4. We're going to get rid of all of this. All right. So how would we solve for this? What this would be is going to be, remember, isolate your variable. We're going to subtract 3 from both sides. And then we have x this cancels out, positive 3 minus 3, that cancels out. And then we have our greater than sign. And then we have 4 minus 3, that's 1. Okay, so the values of x has to be greater than 1. So I'm going to draw my number chart. And I'm going to put 0 on here. And where would 1 be? So remember, now we know about rational numbers. So we know that there's positive numbers and there's negative values as well. So my 1, this is a positive 1. It's going to be right here, or wherever you want to plot it. So it's going to be right here. That's my number 1. And when I look at my inequality sign, I see that it has to be greater than or less than. So there's two things I need you to keep in mind, and we should have learned this, I believe, last year. But what you'll have is either an open circle or a closed circle. Okay, open circle means that you have a less than or greater than sign. And if you have an equal sign, then it could be less than or equal to, or it could be greater than or equal to. Okay. And so basically, what this means is that your value has to be either less than or greater than whatever the number is that you're comparing it to. Or in this case, if we have the closed circle, it can also include that value as well. Okay. So we have our 0, we have our 1. So remember, this is a greater than sign. It does not have a line underneath it. So it's going to be an open circle here. And where would all the values be? Well, x could be any value that is greater than 1. So where would all the values that are greater than 1 be? They're going to be this way. So you're going to draw your arrow, and then you're pretty much done. So what you're saying is that all of the answer choices that makes this a true statement is going to be not including 1, but anything that is greater than 1 all the way up to infinity would make this a true statement. That looks like an 8. And that really doesn't look that great either. All right, so that's just a little bit of background information in terms of what we're going to be working on. So in our next video, I'm going to actually show you how to solve this problem that we have here. But I just wanted to give you a little bit of information so that you are good when we work through the problems. You understand what the open and the closed circles are, remembering that we are still going to isolate our variables, and understanding how to graph it on a number line.